We're now going to look at how to calculate probability when we're looking at a contingency table. So a contingency table is a table used to organize the results from a survey where each respondent was asked two different questions. So we have a contingency table here where a large group of friends, a very large group of friends, is getting together for a game night. They decided to take a survey of which game each person wanted to play, as well as the snack they wanted to have while playing. Each person was only allowed to choose one game and one snack. The results of the survey are shown in the contingency table below. So we can see for the snacks, the options they were given were pizza rolls, chips and dips, and cookies. And then for the games, they had a choice between poker, Trivial Pursuit, Monopoly, and Wii Bowling. When we read this table, the totals for each snack are in the bottom row. So there were 44 people that chose pizza rolls, 41 people chose chips and dip, and 30 people chose cookies. And then the totals for each game are in the last column. So 25 people wanted to play poker, 29 chose Trivial Pursuit, 38 people want to play Monopoly, and 23 people chose Wii Bowling. The number in the bottom right corner is the total number of people that were surveyed. And you can find this number by either adding up the total for the total column or by adding up the bottom row. You do not do both, pick one or the other. Then on the inside part of the table, this shows you the overlaps. So these 10 people are the 10 people that chose to play poker and eat pizza rolls. These 8 people also wanted to eat pizza rolls, but they wanted to play Trivial Pursuit. These 3 people wanted to play poker, but they wanted to do so while eating chips and dip. So this is a quick summary on how we read these contingency tables. And now we're going to look at how we can use the contingency tables to answer a few probability questions. So the first question is, find the probability that a randomly selected person wants to play poker. So we want to find the probability that somebody chose poker. So we're going to do that by finding the number of people that chose poker, and we're going to divide that by the total number of people. So looking at my table, if I look across the the row for poker, we can see that there are 25 people that chose to play poker divided by the 115 people that were getting together. 25 divided by 115 is 0.2174. We always want to turn these into decimals. We don't want to leave them as fractions. And as a reminder, we always want to round our probabilities to 4 decimal places. So the next one, find the probability that a randomly selected person wants to have cookies. So the probability of cookies equals the total of cookies divided by the total number of people. So if I look down the column for cookies, there were 30 people that wanted to have cookies divided by 115 total people. And that gives us a probability of 0.2609. The next question, Find the probability that a randomly selected person wants to play Trivial Pursuit and have chips and dip. So for this one, we're looking at playing Trivial Pursuit and having chips and dip. So probability of Trivial Pursuit and chips and dip. So for this one, we're going to look at the overlap. So we're going to look at the Trivial Pursuit row and the chips and dip column, and we're going to find the number of people that chose both of those items. And I can see that there are 14 people that chose both of those items out of the 115 total people. And that is a probability of 0.1217. Find the probability that a randomly selected person wants to play Monopoly or have pizza rolls. So now we're looking at or. They want to play Monopoly or have pizza rolls. So that means we could get someone who wants to play Monopoly, or we could get somebody who wants to have pizza rolls. It doesn't have to just be the people that want both. So probability of Monopoly or pizza rolls. So the first thing I have to ask myself is it possible for these two things to occur at the same time? So I'm going to look at where these are. So Monopoly is a row and pizza rolls is a column. So if I were to highlight these guys, here is all of the outcomes for Monopoly, and here are all of the outcomes for pizza rolls. And notice that when I do this, there is an overlap. So because there is an overlap, these are non-disjoint. There is the chance for this to happen at the same time. So that means we need to follow the formula for non-disjoint probability. As a reminder, that is the probability of A plus the probability of B minus the probability of A and B. So I'm going to find the probability that somebody wanted to play Monopoly first. And that, I'm going to erase this pink highlighting because it's really hard to see, is 38 out of 115. Probability of B would be the probability of somebody wanting pizza rolls. So that is 44 out of 115. And then we subtract the overlap, the probability that somebody chose both, which would be 14 over 115. So 38, that's how many people want Monopoly. 44 is how many people want pizza rolls. But because I counted the 14 people that wanted both twice, once in the 38 and once in the 44, I have to subtract it now so that they're only counted once. That gives me 68 out of 115, which is a probability of 0.5913. There's another problem here. Find the probability that a randomly selected person wants to play Wii Bowling or have cookies. I recommend you take a moment to pause the video and see if you can figure out the answer to this one on your own. It is very similar to the one that we just did. So I'll give you a moment, pause the video, work it out, I'll stop talking. All right, hopefully you paused the video, you've worked it out, and now we can go over the answer. So the probability that somebody wants to play Wii bowling or have cookies. So it's the same formula as last time because we have Wii bowling, which is a row, and cookies are a column, so they overlap. And I can see this very clearly if I highlight. Here is my row, here is my column. I can see that overlap very clearly. So the probability of somebody wanting to play Wii bowling is 23 out of 115, plus the probability that somebody wants cookies is 30 out of 115, minus the probability of somebody wanting both was 4 out of 115. 23 plus 30 is 53, minus 4 is 49 out of 115, gives us a probability of 0.4261. And that is how we find basic probabilities and also probabilities involving and or using contingency tables.